Hello once again. Today we're going to be talking about inscribed angles, and for the first time ever we're in front of a live studio audience. Yes. Out here in internet land, they are our live studio audiences. I know you've just gotten very scared. Okay. All right, well let's go ahead and get started. This is what we call string art, which was really popular in the 70s. And I've done some of this myself. The idea here is you go put some nails in, and then you go kind of like spirograph, and you go, oh, you know what? I don't have my thing plugged in. So this is what, all right, my pen wasn't working, now it is. So here we have nails, and they're all the way around the circle. And what you do is you connect this with a different part, and you keep going like this until you have all this pretty artwork done. It was very popular in the 70s. All right, so all of these right here are what we're going to call inscribed angle. They are angles whose vertex lies on the circumference of the circle. So far, so exciting. So let's take a look up here. An inscribed angle is an angle whose vertex is on a circle and whose sides contain the chords of a circle. So I'm going to go ahead and draw one now. This is an inscribed circle, right there. That's an inscribed circle. The intercepted arc consists of the endpoints that lie on the sides of the inscribed angle. This is the intercepted arc, and a chord or arc subtends an angle if its endpoints lie on the sides of the angle. So that chord right there subtends the angle. So here's the boring stuff that the book says. All right. That's my live studio audience again. All right, that's it. It wasn't that funny. It actually wasn't funny at all because no one laughed in the first place. Anyway, DEF is an inscribed angle. DF is the intercepted arc, and the arc DF subtends that angle. Now here's the interesting thing. You'll remember back, and this I will actually turn to somebody in the classroom. The measurement of this arc was the same as what measurement? The angle, which, yes, Brenda?
Central angle.
The central angle. Well, the interesting thing is the inscribed angle is half as much as the central angle. Okay? And that's what this kind of confusing formula tells us right here. Okay? So, half the intercepted arc. And there's 3 different cases. We're going to move on. So, if the whole arc is 118 here, it would mean that the central angle is also 118. 118. Therefore, the measure of the inscribed angle is half as much. We come over here, 118, to magic calculator, whose numbers don't work so well, divided by 2. I could have done it in my head, but I wanted you to see it. So, PRU, the measurement of PRU is 118 divided by 2, which is 59 degrees. It's half the measure of the central angle of the arc that it surrounds. So, if the central angle is 118, this one's 59. Okay? Very, very exciting. Here's another one. Find each measure. ADC. So we want to find the measure of the arc. ADC. This arc over here. Okay? So we know that ABC is 135 degrees. Therefore, the arc around here is twice as much, which is 270 degrees from there to there. And what they want is they want the measurement of, I think ADC, we just found it. There it is. So because the inscribed angle is 135, ADC is twice as much. 270 degrees. Because remember, the inscribed angle is always going to be half as much as the arc that it's intercepting. So here we are back to some beautiful string art. It's not very big. I'm going to go ahead and make it bigger because it's not very big. Oh, I guess I can't make it big. Okay, well, there you go. That's why it's not very big. All right, let's go do this problem. Find the measure of angle A, B, D. So we're looking for this angle right there. I'm going to make that white so you can see it. We're looking for the measurement of that angle right there. And the measure of the arc BC right there. All right, let's go try to figure this out. We know that because this is 60 here, the inscribed angle is 60. Therefore, the arc that it intercepts has what measurement? Anybody in the studio audience following along here? The inscribed angle is 60, so the arc that it intercepts. Yes, Giovanna. 120. How'd you get 120? 60 times 2, the inscribed angle times 2 equals 120. Let's tell her what she's won. No, that is correct. All right, and finally, yeah, there you go. There you go. All right, you're done. All right, very easy audience here. And finally, here we are, 6 minutes into it, we're wrapping this up. The measure of angle ABD. ABD. The arc is 86 degrees. So what's the inscribed angle? Who can tell me? Brenda.
86 degrees.
Really? Because that would be the central angle. That would be that angle there. Once again, we want the inscribed angle. Let's go to Adeline.
43.
So it's going to be 86 divided by 2, which indeed is 43 degrees. Excellent. And so finally, here is your problem of the day that you're going to fill in on the Google Forms. So go ahead and do this problem, and we'll see you next time out here in Internet Land.